Good, hi. Then let me start. So I'm Jan from Nitrokey. I'm not having prepared a whole presentation just to present to you. Instead, this is just a discussion I want to initiate and just give some introduction to this discussion I hope to have here with you. So it's about heads. You know, heads is a firmware mostly developed by Thierry, and the presentation stopped working here. Okay. Here we go. Okay. So in a nutshell, heads is a specific firmware to mitigate evil mate attacks through measured boot mechanisms, which relies on a USB key, like a physical USB key, like from Nitrokey, as a root of trust. So when you boot up your system, the integrity of the installed firmware in the computer as well as the operating system essentially is then measured by utilizing the Nitrokey as a root of trust. So this is kind of unique security feature only heads provides so far. And it's often combined with Cubes OS, since both target high security environments, so that's a good fit. And this is why we also pre-install it on our Nitro pads. And technically, just very high level, it's core boot based with a Linux payload where this security feature is implemented. And then this boots an operating system like Cubes or another one, a Linux based one. And we love heads. But now we ship it also since a couple of years, and we have learned some lessons. And this is what I want to discuss here with you, if we can do better. So, and one of the main concerns and complaints of our users is that this entire measurement needs to be executed again, and there's of course a re-signing involved when the kernel is updated. And many users don't understand this, and in fact if you compare it to ordinary PC users, this is in fact complicated. I can understand this. And maybe not so far for this crowd here. I think most of them are very technical, but so for ordinary users. And this is a burden in order to make heads more popular and get more users on heads. And some even want to use it for Windows. Not so many private users, but more enterprises. There are in fact some enterprises, of course, using heads, but then as it requires now a Linux-based system, they combine it then with, say, Ubuntu or Cubes. But many enterprises would like to use this then with Windows. And that's not possible because of the K-exec mechanism used here. In general, usability, I think, improved a lot over the years, but there is still room for improvement, at least from our customer support perspective. There's still a lot of questions from the users, so things could maybe generally be improved. Of course, we would love to see more hardware, being able to boot heads, to use it with heads. And since there's essentially one main developer, one main maintainer these days, I would like to see Thierry more happy, and I think now he has a lot of work to doing with maintaining the system. And so we were digesting this idea for a long time, and this is what I would like to discuss with you. And it's essentially about, hey, can this measured boot feature, which is now unique to heads, be integrated into TianoCore as a maybe considered like a next generation heads? So that essentially you have this security feature in TianoCore, which then would allow users to configure it as some other options you typically can configure from UEFI-based BIOSes and from TianoCore. Since it's UEFI-based, it would allow to start Windows. And it already has some secure boot mechanism. So if then this measured boot mechanism, which we have in heads, which relies on the Nitrokey as a root of trust, if this could maybe combined with, say, the signature key of the Cubes operating system or of another dedicated Linux operating system, or maybe even in general of a Microsoft signing key. So if this can somehow be combined to allow kernel upgrades without re-signing. I think from the Dachau perspective, which now has essentially two flavors, one UFI base, one heads base, this would also unify the code base. Maybe makes development faster, because hopefully maintenance would be easier with a single code base, so that development resources can work more on adding new features, improving the usability. It would perhaps make it easier to get more hardware supported, and hopefully in general reduce the maintenance and efforts of this. So that's a discussion I would like to have with you, so which I'm opening now. So what are your thoughts?
I would go, but like Marek, come.
Yes, please come to the stage.
I just want. Can I? Yeah.
You can use that mic also.
I can. Okay. I will just restate the facts so that we start like the discussion like at the same point. Like when we talk about like a root of trust being in the USB Nitrokey, the actual root of trust is actually in the boot block. The measured boot is starting from there. The boot block measures itself, Sorry, I will restart. So the USB Nitrokey is actually the attestation part, but it's not the root of trust. The root of trust is inside of core boot, measured boot, which starts at the boot block, which measures itself and then measures all the other stage of core boot. And at the end of it all, like it actually has its own tools inside of it to be able to use the extended measurements that were done in the TPM to actually create a sealed secret that was already sealed, and unseals that secret, authenticates with the USB dongle to make sure that it's still in the same state as before. This is just the result of core boot, measure boot, and after that, EDS takes its own subset of measurements to report and extend in other banks of PCRs, and that permits to seal another secret, which will unseal the disk unlock key with a passphrase. So that's just that part.
So can we say that essentially Nitrokey attests somehow?
Yeah.
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 Local attestation server.
Yeah, like basically yes. So the key is actually an attestation server.
But it essentially attests what was stored inside TPM.
Yeah.
Not the measurements.
Yeah. So the boot block situation in this case is not great.
Yeah.
So my question would be, isn't it better to use the RTM? Because you don't have this boot block problem there.
It would, but then again, like it requires other blobs, and that's where like it's always the same. I don't have a clear answer on that, but yes, it would be nice. But like going there, we talked a little bit like of this conversation, and for EDS to be able to work in that way, since we don't rely on grub, which you do, would mean like key exec.
Do you actually need a grub? It's like we currently.
I think this kind of diverts from this topic,
sorry.
doesn't it?
By yes and no, because like if we want to merge, let's say in TianoCore, or it's either we continue and we merge inside of EDS, or then we get outside. That's the mind game we're playing in this talk right now. So let's remove EDS or merge efforts inside of EDS. How do we get one thing that do both, use measured boot, and you will be the maintainer of this discussion, like if we go off track, I think. But like from my perspective, that's it. So yes, the RTM would be nice, but then inside of EDS that requires key exec.
Yeah, and
that where you could jump from what you know, because we discussed this like on the dinner today.
Yeah, I don't know if this is a good segue. Because if let's go to the slide with the with the concept, not this one.
Next one.
So the first problem I see, what would be the feature parity with heads? Because I think theory assumes that there have to be Linux kernel there, so that's essentially neglect the UFI. If not, then mimicking all the features that heads already have inside UFI is a big problem, because first of all, PGP. you have to port PGP to UEFI.
Doesn't need to be PGP, I think. Like I would say it's implementation detail. Like
So
currently
that's what
use
my
PGP,
that's my question. That's my question. What kind of feature parity we should achieve?
Yeah,
Yeah.
that's kind of what I have in my head as well.
Yeah, I don't think in this approach you need to like match heads exactly, like just replace firmware and it's compatible with the same boot part. I don't think that's realistic. So if there is something that would make it nicer, and also GNU-PG as an implementation of the standard is not currently the preferred one, I would say. So there are, we have some alternatives now. So yeah, I don't think we should focus to keep it like heads, but
That is very important kind of segue because we were inquired about the use of Open PGP CA project of NLNet inside UEFI. So, but when I asked this to Christian and Sergey, they kind of suggest me that I'm crazy, and that's not easy thing because then you have even Sequoia Rust stuff to integrate in UEFI. It's kind of already going into area of quite expensive project.
It's not easy, definitely.
Yeah.
Yeah.
But I think the angle there would be also. You correct me, but like the goal would still be to use the security dongle to do operation, which is an open PGP card, meaning we have to respect that standard. As of now, there's 2 dongles for HOTP.
You have token which support different things.
So I think there could be different potential solutions being considered. So OpenPGP card is a standard currently used, but it's a device standard, so kind of interface of the device. It doesn't necessarily mean you need to use OpenPGP or GNU-PG. You can just use a plain RSA signatures and decryptions and keys for whatever your own format, if you like to, or something entirely different, maybe even FIDO, if you make use of.
And I think you
that.
also support Nitrokey specifically supports also X509 signatures or something like that. It's the different tablet on the token.
PIV, I
yeah,
guess.
exactly.
Yeah, you can use X509 with PIV interface and OpenPGP card interface as well. It's not that popular, but it's possible.
Yeah, it doesn't need to be PGP.
Okay, but let's try not to go too much into detail, I would say, because there's 15 minutes left or so.
Oh, right.
So, yes, this was now about efforts. Yes, it is not, it would not be a simple effort, a simple project. There would be tools to be integrated, whatever tools, whether it's Sequoia or GNU-PG or maybe something smaller. There are already some cryptographic mechanisms available, so it might be, some of them might be useful here as well.
So,
and beside of the efforts, so do you see any roadblocks of this in general?
I think it's very interesting use case if you connect this with bootguard. So you protect also the boot block, like with bootguard, and then you have kind of more open UEFI secure boot, I would say. Because UEFI secure boot is tied to specific keys you need to it's forcing some specific key hierarchy on you. But here you can be more flexible. You can support users key for different things and not everything with the same key. Yeah, I think it may be interesting case for.
Yeah, I'm trying to think about that and how is this different from UEFI secure boot or just adding to UEFI two-factor authentication with the token.
Well, UEFI secure boot itself it assumes your firmware is in a good
But you
shape.
can provision it.
You can provision it with your own keys, but still the thing that verifies if the signature is good on your bootloader or
Okay, so
kernel,
you mean
is-
delegation to USB
yeah.
token? Okay.
Yeah, and here we still rely on boot block being not compromised.
So,
which
so
can
we're saying
solve with
about
boot block.
sorry. So we're saying about UEFI secure boot with delegation of the signature verification to the.
Or actually attestation with attestation of the thing that verifies signature if it's still in good shape. So you have external verification if the whole firmware that later will verify your signature is still in good shape.
Understood.
Yeah. So it's a bit stronger, I think, maybe.
I just want to go back like to this point, like defining. That's something that I
Yes.
challenged you a couple of times before, like this problem, the first one. So, kernel updates without resigning. What's your take? Like how can, because that's the main issue for edge users, that's for
Yes.
sure. But like without trying to change everything, like I'm not addressing the second point here, like UEFI would need to, or otherwise we need shimming and everything that oh my god, I don't know, like inside of it right now, but like the kernel updates without resigning. So
Yeah, so for that we the distribution, pick some distribution of choice, would need to ship kernel binaries with some kind of signature. It could be detached signature or it could be UEFI secure boot signature, some kind of signature on. We will have this with work on secure boot anyway. Maybe we could also ship detached signature for all the binaries, so we don't run into some of the secure boot problems. But it's a bit complicated in with the way we currently build packages, because we first build everything, including and package this into RPM, and this environment intentionally doesn't have access to any signing keys. Signing is done later, but you have all the
after the fact.
yeah. So it would need to unpack, to sign and pack again or something. It's a bit complicated. Yeah, so we can think about how to schedule that work and like prioritize and maybe get some funding to rework some of this, but it's not a simple change.
Yeah. Because to me, like it goes back to DKexec point that I was having before. If I follow the discussion, we're going in the path of UKI. So if this is the case, then your main problem, if I understand correctly, would kind of disappear in one rock, two stone. And if the key exec work, more discussion, we're not going to fix this today, but like if key exec was able to verify the signature, because key exec is supposed to be able to do that.
In Linux, yes. In Zen, not yet.
Ah, okay, so it's another problem. Okay.
But you have Linux as a payload, so it should work.
Yeah. So we would be able to verify if the binaries are signed and we already know the signature. Basically, the first problem would disappear if the work was done.
Yes.
And then the RTM question mark.
Is this kernel updates? Do you want to get this on the attestation side or just what the firmware loads?
I can try to do it like in 15 seconds, but like the attestation of the firmware is one part, communicates with the key, says it's good. After that, like the verification of everything else being, runtime is validated to unseal the secret. Once that is done, the verification of your default boot is verifying the content of what was signed by the user key inside of /boot. So that's the part that we're talking about here, because if you install updates, you reboot, then the kernel initRD xen grub configuration will change. The user is prompted with the files that have been changed, and there's issues on that because we would like to give more information to the user. Like, is the grub configuration changed because it's textual? Should we use Git? We don't know. But as of now, like, we have this debate of why should we deal with that? Because if the OS was doing with that correctly, then it would be a non-issue for the whole ecosystem, not just ads.
Yeah, so the improvement in this area is to like have this because currently heads basically verifies the boot files like kernel internal has the exact same hash. And if changes, then user needs to do something. But that could be changed to a verification if it's signed with the same key as before.
Exactly.
So after update, you don't need to resign everything.
That would be
Grub config is still a bit problematic, but yeah.
But if we're
Maybe some.
UKI, then the grub configuration will be...
You still have the version in the file name, and
Okay.
so grub config would change. Maybe we can abstract it out some way. I don't know. Yeah, but that would be a single file that change and not like 5 of them.
And then introspection, being able to check what's inside of the file, checking if the kernel boot options change, blah, 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 blah. That would be possible. Like if there's work there, your first thing just disappears.
So some comment from Demi. DRTM requires being able to reset PCI devices effectively, so SRTM still has its place. I don't know how to comment that. Linux is not a good choice. That's Demi comment. OpenPGP
Is TianoCore better? Maybe
it looks like the alternative is between those two. OpenPGP is not a good choice either.
Yes.
ED 255.19 signatures are better. Can I assume that the goal is the same level of security as heads, but not a drop-in replacement? That's a question for you.
I would say yes, exactly.
You don't need OpenPGP. OpenPGP should be written in Rust because of how complex the
Thank you, Demi. We know.
But OpenPGP cards can be used without OpenPGP.
Yes.
Yeah.
Yes.
So from my perspective, UK signed by ITL solves the signing problem. SRTM and RTM are complementary. Bootloader spec can solve the grub problem. Also, grub config can itself be signed.
So this is kind of extension of SRTM. So you have a USB token that verifies if SRTM measurements are correct.
Static at boot. Prior typing your password.
Yes,
It's
exactly.
basically that, making sure that where you type your password is safe. That's the goal.
Which is kind of similar to anti-VLMate, which use DRTM compared to SRTM. Yeah. So that's, I think, the good summary here. So
you do DRTM with a real root of trust.
well, with bootguard you still have that.
So no, this is a different place for the root of trust. This is different. So in bootguard you have fuses.
Yes.
And static code root of static code root of trust for verification is in ME. Yeah, correct.
No, it starts in ME.
Or ACM.
Yeah,
ME
verifies
ACM.
the
ME.
yeah.
So and with DRTM you have CPU which verifies ACM.
Yeah, I think so.
Yes.
So the root of trust is not the root of trust. So according to Christian, who explained that to me, he's saying that in DRTM CPU is the root of trust.
Yeah.
But
That's what I get.
then, well, in both cases you trust DPM, and what other differences we have?
Yeah,
That's it.
that's the main difference.
Yeah,
Just
yeah.
want to highlight that.
Just
that
like
there is different
maybe
ways.
just for the sake of the discussion, like what happens there is that basically you trust the ACM blob, which will be loaded by the processor only if it's signed by the keys of Intel, and then
We
the
hope
ACM.
so.
Yeah, that's it. Hopefully, we're trusting another key, but yeah. So the goal there is like ACM is loaded, and then ACM is in charge of the TPM in this weird mode that is the only controller of the TPM. And then it measures the boot block inside of PCR0, which gives us the guarantee that we want. No? Correct.
I don't think the RTM is possible at that early stage at the boot block.
So, I mean,
But IBB and everything else.
TXT did measurements of
Yeah, that's the
CR0,
goal.
but only on servers.
Only on servers.
Yeah.
No.
I don't know if it is like possible since this convergence of bootguard and TXT, but
This is like slightly going off topic.
Yeah.
Yeah, well, okay.
And what you as the main developer of heads think of this idea?
So that will also mean re-implementing all the stuff that is currently in Bash in something more sensible.
I would love to duplicate myself. And that's what I would say. Like, if funding is unlimited, everything's possible.
Yeah, the last bullet is the most important one.
Yeah, but like, I would say this questioning of everything doesn't make me happier for the moment. That's for sure. But like, yeah.
It said happier, not happy.
No, he's already happy, I assume.
But I don't think we will resolve that today. But like, it's
We're working on this.
it's an interesting, Questions from the audience? We have 2 minutes.
Maybe sum up. Yeah, I understand that. So essentially, we agree that UEFI is possible. Like the same property or similar properties are possible in UEFI. It will lead to a lot of choices. Like,
just looking at this slide, I think this approach would give you a unique feature of having anti-will made for Windows, if somebody likes that. Because I don't think anything else, well, BitLocker kind of does that, but it's kind of only.
No.
Yeah, so, yeah.
the point is open DRTM because
Yeah.
I wouldn't say it is that simple for at least Intel to perform DRTM with Windows. Like you need this specific MLE header inside the binary you want to execute. So
Also, then you got the problem. You need to integrate this with BitLocker or something. I think for Windows, it's I think more complicated.
Right.
No conclusion today.
Yeah.
Okay.
Right.
That's
Good.
it.
Thank you.
Thank you.
Thank you.